Right? Tell me. Number. All right. Let's finish this first portion, and then we'll get into that. The observation, parity, divisibility. Let's see if you've made headway there. Problem 4. X squared minus y squared is 1574. X and y are natural numbers. Okay? Now, obviously, the only thing that you can do to begin with is to factorize, right? X plus y into x minus y. One simple observation. X plus y minus x minus y is 2y, isn't it? Which is an even number? That's an even number, is it not? Right? Now, which means this number minus this number is an even number. The difference of two numbers will be even when either both are even or both are odd. Yes or no? The difference of two numbers will be an even number when either both are even or both are odd, isn't it? Isn't it? The difference between two numbers would be an even number when either both are even or both are odd, right? So, which means only two possibilities. Both x plus y and x minus y even. That's possibility 1. Possibility 2, both x plus y and x minus y odd. These are the only two situations that are possible. Now, when both are even, then their product must be a multiple of 4. The product of two even numbers must be divisible by 4, yes or no? Right? Which means x plus y into x minus y must be a multiple of 4. Hey, so the left hand side is a multiple of 4, but the right hand side, is it divisible by 4? No. Is the right hand side divisible by 4? No, because the last two digits are not divisible by 4. So it's not divisible by 4. But the left hand side is divisible by 4. So is this possible? Left hand side divisible by 4, right hand side not divisible by 4. That's not possible. Right? So this case ruled out. This case ruled out. Absolutely. Second, when both are odd, then the product would be odd. Product of two odd numbers is an odd number, isn't it? When x plus y and x minus y are both odd, then the product will be odd. Hey, that means the left hand side is an odd number, product is odd. The left hand side therefore turns out to be odd, and the right hand side is even. Is the right hand side not even? Right hand side even. So is this possible? No. That means I can't have natural numbers x and y for which x square minus y square is 1574. That's impossible. That's impossible. Isn't it? Okay, even I'll actually let you spend more time with 5 and 6, but maybe before that, let me also maybe expose you to the factorizing methods. The factorizing methods. Two things before I venture into this. One, of course, like I told you, xy minus x plus y plus 1, I told you right at the very onset, could be written as x minus 1 into y minus 1. Use this as a standard template in the class wherever required, right? The second thing you might want to take notice of is an expression of this kind, x squared minus x into alpha plus beta plus alpha beta. An expression of this kind once again would appear time and again. If you realize, this could be written as x squared minus alpha x minus beta x plus alpha beta, right? It could be written this way, which is like x into x minus alpha minus beta into x minus alpha. Is it not? Is it not? Right? Which is to say that x minus beta into x minus alpha. Right? So every time you have an expression of the kind x squared minus x into London plus Patna plus London Patna. Right? If you have an expression of the kind x squared minus x into London plus London Patna, you could write this as x minus London into x minus Patna. Always. Right? So these are two results that we would use time and again in our endeavor to solve problems, integer problems using factorization. Clear? Got me? So let's look at the first one. We want to find all two-digit numbers, sum of whose digits is also the product of digits. All two-digit natural numbers, x and y, xy is a two-digit natural number, and what we are seeking is, so this is the units place, this is the tens place. This is the units place, that's a tens place. That means the sum of the digits is the product of the digits. X into y, this is not xy, this is x into y. This is xy the number, but this is x into y. That's the condition of the problem. That's the condition of the problem. That's given. X and y are the two digits of the two-digit number. This is the sum of the digit, this is the product of the digits. We want to find natural numbers x and y that satisfy this. One thing, out of inspection, you can say that x must be y must be 2. Because if 22 is a number, sum of the digits 2 plus 2 is the product of the digits 2 into 2. Isn't it? So from inspection I can say x is 2, y is 2. But let's be explicit about this. Let's get really explicit about this. And now you've arrived at xy minus x plus y equal to 0. Does this look like a familiar domain? Yes, because if I add 1 to this, then this would be completely factorizable, isn't it? Beginning of the class I told you. So this could be then completely factorized as x minus 1 into y minus 1. That's the left hand side, right? And the right hand side is 1. X minus 1 is a natural number, y minus 1 is a natural number. Their product is 1. The only possibility is each must be 1. Each must be 1, isn't it? Product of these two natural numbers is 1. What's the only possibility? Each must be 1. Each must be 1. That means x minus 1 must be 1. Y minus 1 must be 1. That leads us to an exclusive x equal to 2 and an exclusive y equal to 2. Conclusively, the number must be 22. The sum of the digits is the product of the digits. That's the only two-digit number for which this can happen. When you experiment at home, find all three-digit numbers enjoying this property, find all four-digit numbers enjoying this property, and see what transpires, right? Okay, let me get you on to the next one. So do you realize that this expression comes in really handy? Knowledge of this expression comes in very handy. Okay, so keep track of this expression, keep a tab on this expression. Okay? Have you been able to register this, Utsav? Perfect. Okay. The second problem belonging to the variety where factorizing becomes almighty. We want to find integer values of a, for which x squared minus x into a plus 10 plus 10a minus 11 is 0. We want to find integer values of a. We want to find integer values of a for which an integer x satisfies this equation. For which an integer x satisfies this equation. That's what we want. Hey, remember this template? X squared minus x into London plus Patna plus London Patna. Isn't it? X squared minus x into London plus London Patna is going to be x minus London into x minus Patna. Clear? So then part of the left hand side is expressible as x minus 10 into x minus a equal to 11. Isn't it? Now 11 is a prime number. 11 is a prime number. Yes or no? It can't be fragmented into any further composites. Clear? And this is product of two integers. X is an integer, a is an integer. So x minus a ought to be an integer. This is an integer. X minus 10 should also be an integer. So the left hand side is a product of two integers. The only possibility is, the only set of possibilities is, say, possibility 1, x minus 10 is 11 and x minus a is 1, isn't it? This is one possibility. Would you want to deny this? One of them must be 11, the other one must be 1, because this is a prime number. Right? This gives me x equal to 21 and a equal to 20. A equal to 20. Isn't it? I get x equal to 21 and a equal to 20. Right? That's one possibility. Possibility 2. Just reverse the roles. X minus 10 is 1 and x minus a is 11. Isn't it? X minus 10 is 1 and x minus a is 11. That's the next possibility, which leads us to x equal to 11, and when x is 11, a is 0. When x is 11, a is 0. That's another possibility. I have not yet exhausted all possibilities. I could have had this one as minus 11 and this one as minus 1. Isn't it? I could have had this as minus 11 and this as minus 1. Is it not? So x minus 10 as minus 11 and x minus a as minus 1. That's another possibility. Now this gives me x equal to minus 1. When x is minus 1, a is again 0. When x is minus 1, a is again 0. And you can swap the roles. The fourth possibility would be when x minus 10 is minus 1 and x minus a is minus 11. That's a fourth possibility, is it not? Right? So x minus 10 is minus 1 and x minus a is minus 11. So this gives me x equal to 9. See, x equal to 9. If you put x equal to 9, a will be 20. So what are the possible values of a? A could be 20, 20, 0, etc. These are the various values of a that you obtain from these equations. These are all permissible values of a. That will cause only integer values of x to vanish this. In fact, if this was not 11 but any other prime p, if it was any other prime p, then what you could have said is this could be p, this could be 1. Or this could be p, this could be 1. Or this could be minus p, this could be minus 1. Or this could be minus p, this could be minus 1. Those would be the 4 possibilities then. Thought well taken, registered, right? Okay. Now let's look at 3. We want to find all natural numbers n. In problem 3, we want to be able to find all natural numbers n for which n squared plus 96 is a perfect square. We want to find natural numbers n for which n squared plus 96 is a perfect square. Clear? That means square of a natural number, square of another natural number. That's what it means, right? Which means n squared plus 96 must be some m squared where m is a natural number, isn't it? That's what we want. Therefore, we are seeking natural numbers n and m for which this condition is met. Nahi kya? The right hand side should be square of a natural number m. So we want to be able to find n for which this is square of a natural number. Clear? Okay, no rocket science. Once again, this involves m squared minus n squared is 96. Factorize this. M plus n into m minus n. Right? Now, notice that m plus n, again, like before, minus m minus n is even. Is 2n even? That means either both are even or both are odd. But both can't be odd. Because if both were odd, then their product couldn't have been even. So both must be even. M plus n and m minus n both must be even. So m plus n ought to be even. M minus n also ought to be even. Okay, now we are all set. And of course, m plus n greater than m minus n because m and n are natural numbers. So then let's start looking at this. M plus n, m minus n. M plus, say m minus n is 2, then m plus n would be 48. Right? If m minus n is 4, m plus n would be 24. Right? Isn't it? If m minus n is 8, because see m minus n, m plus n both have to be even. So I am not even exploring m minus n equal to 3, m minus n equal to 5. Those are ruled out anyways. Right? M minus n is 8, then m plus n would be 12. M plus n will be 12. Now, 6, I missed out 6, I am so sorry. M minus n is 6. M minus n is 6, m plus n would be 16. M plus n would be 16. That's it. That's it. I couldn't have taken m minus n more than 8. M minus n equal to 10 doesn't work because if m, see, 10 into an integer will not give me 96. But m minus n equal to 12 will give me m plus n equal to 8. But m plus n is larger than m minus n. So then this is where we stop, this set of possibilities. For each one of them, when m plus n is 48 and m minus n is 2, you can solve for m and n, giving you one pair of m and n. When m plus n is 24, m minus n is 4, you can again get the values of m and n. So by solving these simultaneous equations, you can get all pairs m and n for which n squared plus 96 would be a perfect squared. Yes or no? Sure about it, Supreet? Slightly in doubt. Huh? Sure, no? Okay. Now, fourth. So, useful tool, right? Simple factorization can be a very potent tool. Problem 4. N is a prime number. n is a prime number. That's given in the problem. Okay. And we are talking of natural numbers x and y. We are talking of natural numbers x and y. All sets of natural numbers x and y for which 1 by x plus 1 by y is 1 by n, where n is a prime number. We want to be able to discover all natural numbers x and y for which 1 by x plus 1 by y is 1 by n. Hey, by inspection, one pair of x and y could be x equal to 2n, y equal to 2n. See, 1 by 2n plus 1 by 2n would be 2 by 2n, which is 1 by n. So 2n comma 2n is a solution obtained out of inspection, isn't it? See, inspection will tell you x equal to 2n, y equal to 2n as a solution, because 1 by 2n plus 1 by 2n is actually 1 by n, isn't it? That's out of inspection. But let's see if there is uniqueness about this solution or not, or is there prevalence of other solutions as well to this, natural number solutions to this. Let's examine this. Clear? Okay. Now, wonder where the factorization comes here. All right. When you look at the problem ab initio, there is only one thing that you can do in the problem to begin with, and then leave it to nature to see if it obliges or not, right? So with that courage, let's go ahead and at least simplify matters here. This will be x plus y by xy. The left hand side is going to be x plus y by xy. That's the best that you can do, lazing around with this expression, right? Which then would mean xy minus n into x plus y is 0. See, n xy minus n into x plus y is 0. How's that? Bothers you? Very good, brilliant. Give him a hand, please. And I'll tell you why he thought so, but I really like the way you think, Ishan. Very good. See, again, let's also understand the reason he suggested that. Okay, let me see. I'm attempting to factorize this or condense this, compress this, make it look beautiful, right? That's what I'm trying to do in the first place. Let me look at these two terms, nx and xy. So I get like a x into y minus n. See, if I take these two terms and I take x common from this, then I get like a y minus n. Is it not, Yash? Okay. Now, then there is a term minus ny. See, there is this term minus ny. I would have liked a y minus n to appear in this, so that I could take y minus n common, right? There is a minus ny, but I would have liked it to be minus of n into y minus n, for reasons not difficult to fathom, because then there would be a commonality of y minus n in the two terms, this minus ny. Have I got too obtuse with you, or are you there with my thinking? You know what I'm trying to do? So minus n into y minus n. I force this n squared therefore on the left hand side. To bring about a y minus n common to the two terms, I forced a n squared to the left hand side, and therefore let me remedy it by placing a n squared on the right hand side to make it look even Steven. There was never an n square on the left hand side. There was never a n squared on the right hand side, but I placed a n squared on both sides to make the left hand side look graceful and reachable. And the reason I put a n squared, because I wanted a y minus n common between these two terms. So I forced ny was already there, but n squared was not there. So essentially, on the left hand side, what did I add? N squared. And I balanced it with a n squared on the right hand side. Does it make sense to all of you or not? Now this gives me like a x minus n. I took a y minus n common, so x minus n into y minus n is n squared, right? n is a prime number. N is a prime number, right? N can therefore not be fragmented into further integers. N is given to be a prime number. We are all set. We are actually ready to perform the last rites on this problem. We are done with all the algebraic manipulations. We are now ready to interpret this. But so far so good. I hope you are all fine with what I have done so far on this. Right? But I really like the way you were thinking, Ishan. Very good. See, this is like a n into n, isn't it? X and n are integers. So this is an integer, this is an integer. Y minus n is also an integer. And of course, in this case, it's a natural number. Reason I claim it's a natural number, just to make sure that you don't look at it with hatred. I mean, x could have been less than n, you could have said. You could have said x is less than n. Then also it could have been, what was the original equation? 1 by x plus 1 by y is 1 by n. Now if x were to be less than n, then 1 by x will become greater than 1 by n. Isn't it? Then the left hand side would become greater than 1 by n, given that y is positive. But it's actually equal to 1 by n, isn't it? If x were to be less than 1 by n, if x were to be less than n, then 1 by x will be greater than 1 by n, isn't it? So this will become greater than 1 by n. The left hand side will therefore be rendered greater than 1 by n. So x cannot be less than n. Similarly, y cannot be less than n. X and y therefore both have to be strictly greater than n. Are you all there with me on this? Therefore, they are integers, and if x is greater than n, it's a natural number. X, y and n are integers. If y is greater than n, then this also is a natural number. So this is product of two natural numbers. Product of two natural numbers equal to n squared. Right? Now, let's list out all possibilities from this. Let's list out all possibilities from this. Possibility 1, both equal to n. X minus n equal to n and y minus n equal to n. This will give me x equal to 2n, y equal to 2n. That was a solution we had obtained by inspection also, isn't it? Right, Utsav? 2. Between the two, one of them could be n squared, the other one could be 1. This could be n squared and this could be 1, or this could be n squared and this could be 1, isn't it? So possibility 2, x minus n is n squared, y minus n is 1. So this will give me x equal to n squared plus n and y equal to n plus 1. Right? Third possibility, x minus n 1 and y minus n squared. Reversing the roles, swapping, right? I have x minus n equal to 1 and y minus n squared equal to y minus n equal to n squared. This gives me x equal to n plus 1 and y equal to n plus n squared. So 3 sets of solutions that we've obtained. This one was readily available out of inspection, and once we got into the details, we figured that this is not a unique solution. There were more solutions available. There were more solutions available to this. No, Supreet? Pakka? Lock kiya jaye? Okay. Get yourself this exposure. You would not even realize that it becomes part of your blood corpuscles. It will start flowing through every vein and artery of your body, and you will get into the spirit of the subject. Okay. All right. Now let me explain the most fascinating aspect of it all, which is integer solutions deploying inequalities. Now that's going to be, trust me, in my view, that's very fundamental, very easy, within reach of all, and most fascinating, most fascinating. So deploying inequalities. So let these problems act as my mouthpiece. So the first problem is 1 by x plus 1 by y is 5 by 6, where x and y are natural numbers. Okay. One by x plus 1 by y is 5 by 6, where x and y are natural numbers. Okay. Now one thing, surely x can't be equal to y. Reason x is not equal to y, because if you put x equal to y, you get 2 by x on the left hand side equal to 5 by 6. This gives me x equal to 12 by 5, which is not a natural number, which is not a natural number. So x equal to y is ruled out. X equal to y is ruled out. Right? So of these numbers x and y, one of them must be larger than the other. Say x larger than y for definiteness. Can I then safely assume, say x larger than y? Right? All right. X equal to y is surely not a possibility here if x and y have to be natural numbers. Say x larger than y. Yes, by inspection you can see 1 by 2 plus 1 by 3 is 5 by 6. Say x could be 3, y could be 2. That's by inspection. But that does not guarantee uniqueness. Like you saw in the previous situation, an inspection will tell you a starting point but will not guarantee uniqueness. You will have to further examine for uniqueness, if at all. Right? Say x greater than y. Then we will have 1 by x less than 1 by y. Yes or no? Therefore, in this expression, which is the mother expression, 1 by x plus 1 by y, this is 1 by y is 1 by y. 1 by x is less than 1 by y. So, can I say that this is less than 2 by y? No. See, the way you can look at it is, okay, 1 by x less than 1 by y, add 1 by y to both sides. One by x is less than 1 by y, because x greater than y. Add 1 by y to both sides. Can I say this? So does it not give me 1 by x plus 1 by y is less than 2 by y? Can I say this? Tell me. But 1 by x plus 1 by y is 5 by 6, is 5 by 6. Okay. So this I can write as 5 by 6. This I can write as 5 by 6 less than 2 by y. This gives me 5y less than 12. 5y less than 12, or y less than 2.4? Yes, absolutely. Y is a natural number. And if y is less than 2.4, y could either be 1 or could be 2. Yes or no? So y has only two possibilities, 1 or 2. Right? Now if you put y equal to 1, what do you get? If you plug in y equal to 1, you get 1 by x plus 1 is 5 by 6. If you plug in y equal to 1, you get 1 by x plus 1 is 5 by 6, or you get 1 by x as minus 1 by 6, which is not possible because x is a natural number. 1 by x cannot be negative, right? So y equal to 1 is junk. Y equal to 1 is junk. It could be ruled out. Y equal to 1 doesn't give me a natural number value of x, right? So let's look at y equal to 2. Obviously, if you plug in y equal to 2 here, then as expected 1 by x plus 1 by 2 is 5 by 6, and when you solve for this you get x equal to 3, right? So then I could have had x equal to 3, y equal to 2 as a solution, and the reverse is also possible, because see, I can interchange x and y and nothing changes. Therefore, if a comma b, if x equal to a and y equal to b satisfies this equation, then x equal to b and y equal to a will also satisfy this equation. Now it's okay. On this premise, I got one solution, and now I get into a fresh thought. If a comma b satisfies this equation, then b comma a will also satisfy this equation. That means if x equal to a, y equal to b satisfies this equation, then x equal to b and y equal to a will also satisfy this equation. That means if x equal to 3 and y equal to 2 is a solution, then x equal to 2 and y equal to 3 will also be a solution to this equation. Let me get a little more involved with this thought by looking into the next situation, right? But are you fine with this? Now the next one is x and x, y, z are distinct natural numbers, and 1 by x plus 1 by y plus 1 by z is 1. X, y, z, it's already given, are distinct natural numbers, and 1 by x plus 1 by y plus 1 by z is 1. Again, by inspection, you can see 2, 3 and 6 is a solution to this. X equal to 2, y equal to 3 and say z equal to 6 is a solution to this equation. Natural numbers, dude. Natural numbers, right? X, y, z are natural numbers here and distinct, unequal. Okay. So if they are distinct, one of them must be the largest, one of them the second largest, one of them the smallest. That must be the case. So there would be no loss of generality if I assumed x greater than y greater than z. No loss of generality in assuming x, say, greater than y greater than z. I'll have at least one set of x, y, z that will satisfy this equation, right? I'll have one triplet x, y, z satisfying this equation. Are you okay with this? Now, if x greater than y greater than z, and I take the reciprocals, which is my expression of interest, can I say this? So, of the three, which is the largest? 1 by z is the largest. So, of 1 by x, 1 by y and 1 by z, 1 by z is the largest, isn't it? 1 by z is the largest. Now 1 by x will be less than 1 by z, 1 by y will be less than 1 by z, and 1 by z will be equal to 1 by z, isn't it? Very good. Therefore, if I add to get the expression of interest, I end up getting 1 by x plus 1 by y plus 1 by z less than 3 by z. Can I say this? Doesn't matter. 2 equal to 2, 4 less than 5, 5 less than 6. So this plus this plus this, see, it's like this. 2 less than 3, 4 less than 5 and 6 equal to 6. Now if I add 2 plus 4 plus 6 will be less than 3 plus 5 plus 6. Can I say this? Despite this equality. You know? This plus this plus this will still be less than this plus this plus this. Clear? So I could still say 1 by x plus 1 by y plus 1 by z less than 3 by z. Right? But what's the left hand side? 1. This is 1. Right? So I end up getting 1, this is 1 less than 3 by z, z less than 3. Now there are only two possibilities for z. Z could be 1 or z could be 2. So z could either be 1 or z could be 2. Now z equal to 1 is ruled out, because if you took z equal to 1, then this one and this one will get cancelled, and you get 1 by x plus 1 by y equal to 0, which is not possible because x and y are both positive numbers. So their sum cannot be 0, isn't it? If you plug in z equal to 1, you get 1 by x plus 1 by y equal to 0, which is not possible if x and y are positive, isn't it? So z equal to 1 is junk. Therefore z must surely be 2. If at all, z must be 2. So one of the three we have found. Clear? Let's go further. Let's go further. So far so good. Does it make sense to you? So with z equal to 2, let's write this as z equal to 2. So 1 by x plus 1 by y plus 1 by 2 equal to 1, isn't it? So that gives me 1 by x plus 1 by y equal to 1 minus half. That makes it half. Right? Hey, now if I add these, do you realize that 1 by x was less than 1 by y? Because x was greater than y, 1 by x was less than 1 by y, right? And 1 by y was equal to 1 by y. So if I add these two, then 1 by x plus 1 by y will be less than 2 by y, isn't it? So 1 by x plus 1 by y, which is this, is less than 2 by y. 1 by x plus 1 by y, which is half, is less than 2 by y. So I end up getting y less than 4. Y is less than 4 but is greater than z. See, we started with this, x greater than y greater than z, isn't it? Z has turned out to be 2. Z has turned out to be 2. Y is greater than 2, therefore y is greater than 2, but y is less than 4. So what's the only possible y? Y greater than 2, y less than 4. What's the only y? Y equal to 3. See, y greater than 2, less than 4. What's the only natural number y? 3. Y must be 3, therefore. So z equal to 2, y equal to 3, you will get x equal to 6. Right? So you get x equal to 6, y equal to 3, and z equal to 2. Or we can swap these numbers. This could be 3, this could be 6, this could be 2, and we can swap and we'll get 6 such sets. 6 such sets is what you'll get by interchanging this. You'll get 6 such sets. See, you'll have one set of solution x, y, z, another set of solutions x, y, z. Yeah, I'm saying 6 solutions you'll get. 6. List them out, you'll get 3 factorial solutions to this. 6 sets of a, b, c you'll get, for which 1 by a plus 1 by b plus 1 by c is 1. Got me? Sounds good? Let me get back to the parity stuff that we had. Let's look at problem 6. Some of you came up with an answer. You said there are no such natural numbers n. Let's testify that. Okay. Number 6 of observation and parity, where n was a natural number, n into n squared minus 1 into 5n plus 2 is 24n plus 1. Okay, okay, absolutely. One of the things that you could see from here is that this could be written as n minus 1 into n plus 1. See, this n squared minus 1 I write as this into 5n plus 2. Yes, see, these are 3 consecutive numbers. So, product of 3 consecutive numbers must be an even number. Every time you take any 2 consecutive numbers, one of them must be even, right? One of them must be even. So, the left hand side is even, but right hand side is odd. You can see. Okay, let me change this. So, this is not possible. Let me change this. Let me make the right hand side plus 6. Okay, now right hand side is also even. Let's change this. Now, let's see what transpires. If I do this, see, no, so new problem. Are we averse to a new problem? Cheating ho gaya. All right, let me, huh? Why?
Sir, because n plus 1 and plus n minus 1 is divisible by 6 and the RHS is also divisible by 6.
Huh.
So it will cancel, then we'll get 5n plus 2 will be even and 4n plus 1 is odd. So it's not possible.
Okay, what? Chalo. Then I put it 16. Then fine. I accept everything that you're saying. Okay. Suppose now we change this further. Let me write this as 16. Accept what you're saying. Okay. Let's see if we can take it to that limit. Okay. Does not matter. Let me look at the left hand side. I could write this as n minus 1 into n plus 1. And the number after n plus 1 is what? N plus 2, right? So what I do is I force this 5n plus 2, then 10 minus 8, so that I have 2 preserved. Let me do this, right? I hope you realize what I did. These are 3 consecutive numbers, and I wanted to bring the 4th number in perspective, so I forced it to be 5n plus 2 minus 8. I could do this, right? So this is like a n minus 1 into n plus 1 into n plus 2 minus 8 into n minus 1 into n plus 1. Can I do this? Can I do this? I hope you realize what I did. This into this minus 8 into this. If you remember one of the earlier sessions, I told you product of 4 consecutive integers will always be divisible by 4 factorial. Product of 3 consecutive numbers will always be divisible by 3 factorial. Product of r consecutive numbers will always be divisible by r factorial. In an earlier session, I had spoken a little bit about it. Right? Hey, by the way, why? Just quickly. These are 4 consecutive integers. Okay? So if these are 4 consecutive integers, we must have 2 even and 2 odd in this. We must have in this product of 4 consecutive integers 2 even and 2 odd numbers. So for sure, this will be divisible by 4. 4 will be a factor of this. Yes or no? In fact, in fact, out of the two consecutive multiples of 2, out of the two consecutive even numbers, one of them must be a multiple of 4, one of them must be a multiple of 2. If you take any two consecutive even numbers, one of them will be a multiple of 4, the other one will only be a multiple of 2 but not a multiple of 4. You certainly have two consecutive even numbers here. So one of them is a multiple of 4, the other one is a multiple of 2. So this product for sure is divisible by 8. And yes, these are three consecutive integers. One of them must be a multiple of 3. If you take any three consecutive integers, one of them must be a multiple of 3. So this whole thing is also divisible by 3. So this product must be divisible by 24. Absolutely. Now, these are three consecutive integers. They must be divisible by 3. One of them must be divisible by 3. So this is divisible by 24. So left hand side is a multiple of 24. Is the right hand side a multiple of 24? Right hand side is not divisible by 24. If you divide the right hand side by 24, you get 16 as the remainder.
If we just take the right hand side to be multiple of 6, then also.
Okay, it's not a multiple of 6 as well. You're right, absolutely. Perfect. No argument there. Right hand side is not a multiple of 6. And if we had put this a multiple of 6, for example, 18, then also it will not be true, because it's still not divisible by 24. It's still not divisible by 24. Got me? Yeah, sure. 8 is a factor, and these are n minus 1, n and n plus 1. 3 consecutive integers. One of them must be a multiple of 3. One of them must be a multiple of 3. So 8 into a multiple of 3 will make it a multiple of 24. So this is divisible by 24. This is also divisible by 24. That means the left hand side for n to be a natural number will always be divisible by 24. But the right hand side is not divisible by 24. So the equality is not possible in the set of natural numbers. Clear? Clear now? Let me look at the third factorization, the third inequality thing, which would, this time it's a combination of factorizing and inequalities. So the third part, which is like m and n are distinct natural numbers, and 1 by m plus 1 by n minus 1 by mn is 2 by 5. M and n are distinct natural numbers. Hey, what I do is I reduce it to a known template first. In the sense 1 by m into 1 by n minus 1 by m plus 1 by n equal to minus 2 by 5, isn't it? See, it's like xy minus x plus y. Xy minus x plus y. So I add 1 so that this will become. Absolutely. See, xy minus x plus y plus 1 is like x minus 1 into, or x minus 1 into y minus 1. Yes or no? Or I could also write this as 1 minus 1 by m into 1 minus 1 by n. The factorization that I told you at the very onset, isn't it? That's equal to 3 by 5, isn't it? Difficult? No? Okay. But if they are distinct, let's say one of them is larger than the other, say m larger than n. One of them larger than the other, say m larger than n. So 1 by m will be smaller than 1 by n. Therefore, minus 1 by m will be greater than minus 1 by n. Can I say this? Therefore, 1 minus 1 by m will be greater than 1 minus 1 by n. Right? Yes or no? Now, multiplying by 1 minus 1 by n both sides, so 1 minus 1 by m into 1 minus 1 by n will be greater than 1 minus 1 by n whole squared. Can I say this? Multiplying both sides by 1 minus 1 by n. Can I say this? Can this be said? This was given. I multiply both sides by 1 minus 1 by n. Do I get this? Now what's the left hand side? 1 minus m into 1 minus n is 3 by 5. Right? So the left hand side is 3 by 5. So 3 by 5 greater than 1 minus 1 by n whole square. See, there is a square and this is 0.6. What's the closest square to 0.6? 0.64. Can I say that 0.64 is larger than 0.6? 0.64 is larger than 0.6? Can I say this? Because I want to compare two squares for the ease of it. Can I say this? 0.64 larger than 0.6? So then this must be smaller than this. 1 minus 1 by n whole squared must be less than, right? 1 minus 1 by n whole squared less than 0.64. So this gives me 1 by 1 minus n less than 0.8, right? So this then gives me 1 by n greater than 0.2, n therefore less than 1 by 0.2. So n less than 5. What are the only values of n that you need to inspect? 1, 2, 3, 4. We've reduced the set. The only permissible values of n then would be 1, 2, 3, 4. Find, for every such n, find the corresponding m from this equation. And see if this m turns out to be a natural number or not. Got me? This then, there is some vitality associated with integer solutions. It's genuinely godly. And what I attempted to do was a very modest effort to bring down to you things in their rudimentary form without introducing tools. There are tools that I would introduce down the line, but once you have mental familiarity with all of this, then those tools will flash very easily with your psyche and you'll be able to take things to a different level. But first level of exposure to integer solutions, this then will turn out to be a very, very potent one for you. Keep this, go back home, do these problems once again, maybe make changes here, there, and play with it. Do all of this one more time. Let your mind get completely into the frame of thought. Okay, this much for this time. Have fun. Very shortly, you will see me again with more fun. Thank you very much. I hope you had a good time. Thank you.